This question is from a CCEA paper in May 2011. It is from the C1 module and it is question 1. It begins by giving an equation for a straight line, y equals 5 minus 2x. This line crosses the x-axis at the point A and the coordinates of A have to be found. Y equals 5 minus 2x. The minus 2 is the gradient of the curve. This tells me it is a downward sloping curve. The 5 shows that it crosses the y-axis at 5. A quick sketch will illustrate this. There is 5, there's your y-axis, there's your x-axis, and it will be downward sloping. This is the point A. Now, it crosses the x-axis at A. On the x-axis, y is clearly 0. So A is something, comma, 0. This is your x-coordinate, this is your y-coordinate. A lies on this line. So if I say y is 5 minus 2x, but y is also 0, then 5 minus 2x is 0. If I add 2x to each side, then 2x will equal 5. So x is equal to 5 divided by 2, which is 2.5. So the point A, which lies on the x-axis and is on the line y equals 5 minus 2x, is 2.5, 0, where x coordinate is 2.5 and the y coordinate is 0. The next part of the question talks about the line 3x plus 5y equals 15. It crosses the y-axis at the point B. We have to find the coordinates of B. 3x plus 5y equals 15. It crosses the y-axis at B. Find the coordinates of B. So if I get my 3x plus 5y equals 15, I know the 5y is equal to minus 3x plus 15. I have took away 3x from each side. That there shows me that it is actually going to be a downward sloping. So when I just have a wee quick sketch in my mind, I'll have a line going down like that. This is my y-axis and this is my x-axis. It will cross the y-axis at B. Where it crosses the y-axis, the x-coordinate is going to be 0. So B has got the point x, y, where x is 0 and we don't know what y is. We do know that B lies on the line. So if I write down the equation of the line and put in what I do know, i.e. that x is equal to 0, then I will find out my value for y. 3 times 0 is nothing, and 5y ends up being 15. If 5y's are 15, if I divide each side by 5, then I will get y to equal 3. We now have found the value of the coordinate of point B. B is the point 0, 3. Finally, you have to find the equation of the line parallel to the line AB and passes through the point 1, -5. Note that this question is 4 marks and we need to pay good attention to the mark scheme. The equation of the line parallel to AB and passing through 1, -5 has to be found. To find the equation of the line AB, we need to know the points A and B. If we find the gradient of the line AB, a line parallel to AB will have the same gradient. A is the point 2.5, 0 and B is the point 0, 3. I'm going to call A point 1 and B point 2. That means that I can call this x-coordinate x1 and this y-coordinate y1. I can call this x-coordinate x2 and call this y-coordinate y2. The gradient of the line AB is equal to y2 minus y1 divided by x2 minus x1. y1 was 0 and y2 is 3. x2 is 0 and x1 is 2.5. That gives me an answer of 3 divided by minus 2.5 for my gradient of AB. Now the gradient of AB is negative, and it's not. We need to tidy it up a bit. This here would be a non-calculator question. So I am dividing by actually negative 5/2. To divide by a fraction, you flip and multiply, taking care to continue to hold on to your negative. So the gradient of AB is actually minus 6/5, or 1 1/5. Now, when I move on, the gradient of my parallel line, which is parallel to AB, also is minus 6/5. Now, a line which is parallel to AB is of the form y equals mx plus c, because it is a straight line, and now I can put in minus 6/5 here for x, or for the gradient. C can be found by substituting a point that we know that lies in the line. We know that the point 1 minus 5 lies in the line, where 1 is x and y is minus 5. So if I put in minus 5 for y, and I write down my gradient, multiply it by the x coordinate of 1, I will find that minus 5 is equal to minus 6/5 plus c. The minus 6/5 could be added to each side. So minus 5 plus 6/5 is equal to c. So c is equal to negative 5 plus 1 1/5. So c ends up being equal to minus 3 4/5. The equation of the line, which is parallel to AB and goes through the point 1 minus 5, is y equal to minus 6/5x plus c, which is minus 3 4/5. This here can be tidied up, of course, so we'll put everything, that's going to be 19/5 there, put everything over a common denominator, multiply through by 5, and I'll get 5y is equal to minus 6y minus 19, or 5y plus 6x equals minus 19. So this is the equation of the line parallel to AB and goes through the point 1, minus 5.